Okay, y'all, this is the Unit 5 review, which remember we're putting with Unit 4. And so this is just a shortened video from what it was before because we took a bunch off of this review, so it's only 18 questions. All right, so number 1 says, in the triangle, identify the special segments. And so you need to pay attention to all those markings over there. So a perpendicular bisector, we need to be looking for the line that is cutting a side in half because it says it's bisecting and it's perpendicular. So JF is going to be the line here that not only is it perpendicular, but it is also cutting that side in half. So JF would be our perpendicular bisector. Notice it's not coming from a vertex. It doesn't have to come from a vertex. Okay, the next 3 that we talk about do have to come from a vertex. So the next one is a median. And so here we're looking for the line that comes from a vertex, and it needs to be cutting a side in half. And so if you look at EM is cutting that side in half, and it's coming from a vertex. And then the third one, we're looking at an altitude. An altitude is going to be just that perpendicular line, but it has to be coming from a vertex. So if you look at HG, that's going to be our altitude here. Notice it's not cutting a side in half or anything. It is just a perpendicular line coming from a vertex. And then the last one, the angle bisector. This will be the line that's cutting an angle in half. So you need to see the markings. So you can see the markings there on angle M that it's being cut in half. And so the line that's doing that, again, is EM. So in this case, EM was an angle bisector and it was also a median, and that's okay. It can be 2 things. Number 2, it says find X if segment AB is a perpendicular bisector. As soon as you see what they're calling that, you need to put those markings on there. So perpendicular would mean that those are right angles where the B is, and then it would also mean that that line, that segment is getting cut in half. You want to have those so that then you can see how to set up the problem. So it says find X. So that's 6X plus 5. That's pointing to that right angle right there. So 6X plus 5 is going to equal 90. And I'm just going to solve this. So subtract the 5. So 6X equals 85. And if you divide by 6, I can just leave that as 85 over 6 because that is not going to be a nice number if you type that in the calculator. Okay, part B is a little bit different. It's saying find Y if segment DE. So here's DE. Okay, it's calling that an angle bisector. So that little angle is getting cut in half, which means where the Y's are, those are going to be equal to each other. So I'm going to say 9y minus 10 equals 3y plus 2. So I am going to, I'll subtract 3y first. And I would get, I'm going to work this over here to the right. So 6y minus 10 equals 2. Add the 10 over. So 6y equals 12 and divide by 6. So y would equal 2. I think on the answer key it says x equals 2, but that should be y equals 2. All right, this next question says, given, it gives me these 3 points. So I'm going to go ahead and plot these 3 points. Make sure when you do this that you label the points. That's going to be key here. So here's A, that's at -4 and -5. B, it says, is at -2, 6. And then C is at 3, -2. So again, make sure you're plotting those points because it's going to be important when we draw in these lines. Okay, so it first says, find the slope of altitude BD. Well, to even be able to do this, you have to understand what an altitude is. So an altitude is that line coming from a vertex to the opposite side, and it's making a 90-degree angle. So I don't know exactly where this is going to go, okay, but I want to sketch something in that looks like it could be kind of perpendicular, okay, just to get an idea of what I'm looking at here. Okay, and to be able to work this, what you have to understand is that these two lines are perpendicular to each other. So when this is asking for the slope, what we need to do is we need to get the slope of AC, because I do know those points exactly, and then I'm going to take the opposite reciprocal of it, because the slope of perpendicular lines are opposite reciprocals. Opposite reciprocals. Okay, so I am just going to do rise over run to get the slope of AC. So if I rise 1, 2, 3, and I run 1, 2, 3, 4, 5, 6, 7. So the slope of AC is 3 over 7, which means the slope of BD is going to be negative 7 over 3. So as long as you know to get the opposite reciprocal there, then you'll be able to do that one. Part B says find the ordered pair for E if AE is a median, okay? So median means it's coming from a vertex and it's cutting a side in half. So this one, if it's AE, it needs to be coming from A. So from A to the opposite side. So E is going to be somewhere there in the middle, okay? But I don't know, again, I don't know if I drew that right or not. So the only way to find the exact middle is by using the midpoint formula. And this is another reason why that picture is so important, because you need to know what to get the midpoint of. So the midpoint, in this case, I know I need to get the middle of BC. So BC, I need to get the middle between those 2 points. So the midpoint formula says we need to add our x values together and divide by 2, and then add the y values together and divide by 2. So all I'm looking at is those points of B and C right now. So B, C. So I'm going to have negative 2 plus 3 divided by 2. That's adding the x's together and dividing by 2. It's like getting the average. And then 6 plus negative 2 over 2. That's adding the y's together and dividing by 2. Okay, so I'm just going to work that out. Negative 2 plus 3 is 1. So that would just be 1/2. And then 6 plus negative 2 is 4. Divided by 2 is 2. So this right here is a good example of why I don't want to just guess, because it'd be really hard for me to guess that number of 1/2. So you do need to use the formula so that you can for sure get that point. Now maybe you can come over to your picture and check and just make sure 1/2, 2, that looks like that would be about where that would end up, and it does here. So that's just a good way to check. All right, this next section says describe the possible lengths of the third side of a triangle given the lengths of the other two sides. So this is taking into the fact of, like, remember the two small sides have to add up to be bigger than the third. So when you're just given two sides, you have to say, okay, well, it could be this range of numbers. So the kicker here is you want to add these numbers and subtract these numbers. And that's going to get you your range of values. So you add them and you subtract them. So number 5, if I subtract 8 and 4, it's 4. If I add them, it's 12. So the way that we write this is 4 is less than x is less than 12. Basically, if you read it backwards, it says x is greater than 4, and then if you read it forwards, x is less than 12. So it's got to be more than 4, but it has to be less than 12. Okay, and these will be more like multiple choice questions on the test, but you're going to have to know to add and subtract those numbers. Number 6, same thing. I'm going to subtract them and get 3. I'm going to add them and get 15. So this is 3 is less than x is less than 15. Okay, number 7 and 8, this says list the sides and the angles in order from smallest to largest. Okay, so the smallest side is opposite the smallest angle. The biggest side is opposite the biggest angle. So let's just start with the angles here. I know they give us the angles. So smallest to largest, the angles would be angle P, and then angle Q, and then angle R. So angle P, angle Q, angle R. Okay, and the sides, if angle P is the smallest angle, the side opposite from that is the smallest side. So RQ would be the smallest side. The next smallest side would be opposite the Q, which would be PR. And then the last one would be opposite the 73, which would be PQ. And you can write those points like if I say PQ, you can say QP. That's okay. All right, number 8, I'm going to start with the sides just because that's what they give me. And then I will do the angles. So the sides, smallest to largest. So LM would be the smallest. The middle would be MN. And the biggest would be LN. So that's just simple. Now the angles, I'm going to have to go opposites here. So if if 4 is my smallest side, the angle opposite from that is N. So angle N. The next smallest side is 9. The angle opposite from that is L. And then that leaves M, which is opposite the 11. Number 9, will a triangle be formed using the sides 4, 5, and 9? So here is where the two small sides have to add up to be greater than the biggest side. So is 4 plus 5 bigger than 9? No, it's not. And your reasoning would just be 4 plus 5 is not bigger than 9. I'm not going to write all that out. All right, number 10 says, given DEF and its perimeter of 43, and then it gives the 3 sides, order the angles largest to smallest. If you do not draw a picture here, this is not possible. Okay, so I'm going to draw a picture, and I'll label it DEF, and then I'm going to put all these things on my picture. So it says DE is 4x plus 3, EF is 5x minus 1, and DF is 6x minus 4. Do not set these equal to 180. Okay, we are not talking about angles here. We are talking about sides. You have to be careful of that. Okay, they do give us the perimeter as 43. So we're going to add these together and set it equal to 43. So I'm going to do 6x and 5x and 4x. So that would be 15x's. And then 3 minus 1 minus 4, that would be minus 2. Sorry, I'm just double checking that number. Yeah, 15x minus 2, and that's going to all equal 43. So I'm just going to solve this. So add the 2 over. So 15x equals 45, and if you divide by 15, x would be 3. So there's a lot of steps to this one. None of the steps are really that hard, but you now would have to plug 3 in to get the length of these sides. So if I get the length of DE, that's 4 times 3 is 12, plus 3 is 15. EF, 5 times 3 is 15, minus 1 is 14. And then DF would be 6 times 3 is 18, minus 4 is 14. So you actually have 2 sides that are the same here. This is actually an isosceles triangle. But it wants the angles largest to smallest. So the largest is going to be across from that 15. So the largest is going to be angle F. And then from here, you can put these either as ED or you can say DE because they're actually the same. All right, number 10 is really similar to that one, except this one is giving us the angles. So they say angle, and I'm going to label this ABC. And they say the angle A is 12x plus 1, B is 5x minus 2, and C is x plus 1. And then I'm like, okay, well, what do I know about these angles? These do add to be 180 because we are talking about angles here. So I'm going to add all of these up. So 12x, 5x, and x, that would be 18x. And then negative 2 plus 1, that's 0. So 18x equals 180. So this is a nice, neat one. So x would be 10. So I'm going to take that 10 and I'm going to plug it in to get these angles. So 5 times 10 would be 50, minus 2 is 48. So angle B is 48. 12 times 10 is 120, plus 1 is 121. That's angle A. And then 10 plus 1, angle C, would be 11. And if you want to check, you can always plug these in or type them in and make sure they equal 180. That would be a really good way to check. So now I need to put the sides in order from shortest to longest. So the shortest side is going to be opposite that 11. So AB would be the shortest. The next shortest side would be opposite the 48. So that would be AC. And then that would leave BC to be the longest. All right, number 12. This is kind of, this is one of the hard ones to explain. But I want to start by saying that, like, when it says which side is the longest overall, just because 90 degrees is the biggest angle overall does not mean that A is going to be the biggest, okay? That doesn't translate that way. And so what I would do here is I would pick a triangle to start with. And if it doesn't make sense starting with one triangle, then start with the other one. So I am going to start in this triangle that I'm coloring in red right now. And in that triangle, A is the longest side because it is opposite from the 90. But if you look inside this other triangle, I'm looking at this and I'm like, okay, but the biggest angle over here is 70. And B is opposite from that. Okay, so in that case, A, that side A, is a part of both triangles, but it's not the biggest in that triangle on the top. And so it must mean that B is the biggest overall, because B is bigger than A. Okay, and so you should be able to start with one triangle and go to the other one, and it'll make sense. If I were to have started with the top triangle, it might not have made as much sense. Okay, so if you need help on that, just let your teacher know. All right, these four, the way these will look on the test is basically like this, and we will just give you a word bank and ask you to identify the point of concurrency. So this says, in each figure, tell what point of concurrency is shown and what constructions form that point. So when I'm looking at 13, I'm looking and I see 3 perpendicular lines drawn from vertices, which means these are altitudes. Okay, so those are formed by altitudes. To my classes, I gave like 4 different words that would help y'all remember the point of concurrency. And the point I gave y'all was alto. Altitudes have an orthocenter. Orthocenter. So that was the word, that's the point of concurrency where those 3 lines meet. Okay, the second one, I'm looking at it, and I can see that these are lines that are cutting sides in half. But notice they're not perpendicular, they're just cutting them in half. So these are medians. And the word that I gave y'all here was cement, but we wrote it like this, and we said if we have medians, they make a centroid. Okay, so the point where they all intersect, that is called a centroid. There was also a sentence y'all could have memorized to help you remember these. Okay, number 5, I'm looking at these and I'm like, okay, these lines are perpendicular and they're cutting sides in half. And so what we call these are perpendicular bisectors. Perpendicular bisectors. Okay, and the word we gave y'all here, it's not really a word, it's more like a phrase, I guess. PBC, so whether that's peanut butter cookies, peanut butter crackers, whatever helps you there. But perpendicular bisectors have a circumcenter. So that's the name of that point where those 3 lines intersect. And then the last one, I noticed that all of these angles are being cut in half. So these are angle bisectors. And the point where they intersect, what I gave y'all here was the word cabin. Angle bisectors have an in-center. In-center. Okay, so whatever helps you remember those, use it so that you don't miss those. But those will kind of be like matching type questions. And then the last two here, number 17, what is the relationship between the lengths of DC and AD? Okay, so I can see that DC is opposite from 30. I like to write these numbers down so that I don't have to keep looking back at the picture after this. And AD is opposite from 20. This was something called the hinge theorem, where I'm able to compare those two sides because of something called the hinge theorem. And I can see that 30 is bigger than 20, so DC must be bigger than AD. And then 18, I'm looking at the measure of angle 1, and it's opposite from 15. I'm not saying that 15 is the measure of that angle. I'm just saying that's what it matches up with. And then angle 2 is opposite from 13. So if 1 is opposite from 15 and that's bigger than 13, that measure of angle 1 is bigger than the measure of angle 2. So that's pretty much all you need to know for Unit 5, but just make sure that you review your Unit 4 stuff as well.